And here's some examples of what these improvements to things like the dynamic range look like. Here's some sea ice from Nunavut in Canada from one of the Dove R satellites. Here's another view of sea ice with the near-infrared band thrown in from a SuperDove satellite off the coast of Russia. And here's an example of, instead of RGB or near IR, here's a red edge, yellow, and coastal blue example from one of the SuperDoves. And since we've added these additional spectral bands, you can do some new indices that weren't possible before with the 4-band data. We have NDVI, obviously, from the previous data sets, but if you're working in an application where your NDVI values might be saturated, now you have the ability to do chlorophyll red edge, which was not something you could do with the Dove data previously. So you can do these CIRE indices. In certain parts of the growing season, NDVI can saturate. So if you're using chlorophyll red edge, you can start to look for crop stress. So in this specific case, the red areas here were showing crop stressed examples where there were equipment failures. And so they went and they did drone imagery on the ground to confirm what was going on in the places where they could see stress in the planoscope imagery. This is a zoomed in view of some of the chlorophyll index, and this is made using the near infrared and the red edge bands. Since we have coastal blue now, you can start to look at things like chlorophyll concentration in water and look at turbidity as well. Some of this you could do with the previous generations of the satellites, but you can get a lot better visualizations with some of the added spectral bands here. We're also seeing a big uptake in studies looking at harmful algal blooms with things like the impacts of climate change. And so being able to look at things like chlorophyll and visualizing algal blooms with things like the coastal blue band is something that's been really useful with the 8-band data sets. But we didn't just add more spectral bands to the Planoscope catalog with the SuperDoves. We also made a lot of improvements to the actual data quality itself in terms of sharpness and clarity, data harmonization, and image calibration. So one of the big things, hopefully this animation is playing through on the screen. One of the things that we've really worked on are decreasing hot columns and hot pixels in the data that are caused by sensor overheating. So we developed a new algorithm to catch and fix this on all the generations of doves. This was deployed on August 2nd of 2021, but it was not applied retroactively. So any data that is in our catalog acquired on or after August 2nd of 2021 has this new hot pixel algorithm applied to it. And it's corrected on average about 98% of hot pixels in those reprocessed images. We've also applied huge improvements to the visual sharpness and clarity. And this is from a new sharpening kernel that was deployed to account for changes in the telescope design specifically for the SuperDove satellites. It's a pair-banded sharpening approach, and this kernel is applied to SuperDove visual products only, so not the analytic ones. I think these are being applied from March 1st of this year moving forward, and we're in the process of reprocessing the archive, so that will probably take another couple of months before those have all been corrected. We've also made huge improvements to the spectral band alignment, and this was another thing that was very specific to the SuperDove satellites because you have those 8 small bands across the entire sensor. So in order to make one multi-band composite for a SuperDove image, you need 24 or more individual frames to be combined. This is another one where these improvements have been deployed from March 1st of this year moving forward, and all of the imagery is going through a new compositor and registration process. And this has misalignment down to less than 1.5 meters or less than half a pixel between the individual bands. This is another example of the spectral band alignment improvements with the new sharpening or with the new kernels applied. Another thing that we've offered now is harmonization of the data sets to Sentinel-2. So previously our data was harmonized to our RapidEye archive. If you're not familiar with RapidEye, that was a constellation that we operated from 2009 to 2019, at which point the satellites reached the end of their operational lifespan and they were deorbited. So that whole archive is also available through the NASA CSDA program. We haven't done anything to reprocess that data, but it is there for folks to download. But since a lot of people are doing large-scale studies relative to Sentinel, we wanted to make the data more interoperable with Sentinel, so we have an option now where you can harmonize the data to that. And this is just showing you an example of the uncorrected data versus the harmonized data, looking at NDVI over time. This fix was released on March 1st again. And this is something that shows up automatically now. If you log into something like Planet Explorer, you'll have a harmonize option there. We'll see what that looks like in the interface a little bit later in the presentation. So you have the option of still downloading the data harmonized to RapidEye if it's something that you need access to for continuity with previous data sets, but moving forward, the default option when you select harmonize is for Sentinel-2. We're keeping track of all the scientific publications that we can find that come out of folks using Planet data through things like the NASA CSDA program, as well as our other science programs like our education research program, which is available to anybody at a university anywhere in the world, or our agreement with the Norwegian government called NICFI, the Norway International Climate and Forest Initiative, which is a base map product where folks can study deforestation and forest conservation in tropical forests. And right now we have over 1,800 publications in this list, which is really amazing to see. And they cover pretty much every area that you can imagine in the Earth science system. If we look at some geosphere examples, things like natural disasters, so landslides and floods, earthquakes, these have been really big study areas with our data. And one key example that was pretty amazing was from February of last year. You might have seen this in the news. There was a massive flash flood in Uttarakhand in India that ended up washing away 2 hydroelectric power stations. And the initial reports that were coming out on social media and in different news outlets was that it was triggered by some kind of glacial lake outburst flood or a GLOF. But completely by coincidence, PlanetScope managed to capture 2 images 27 minutes apart, one 10 minutes after the flood started, and the second 27 minutes later, that caught the flood and the landslide associated with it as it was happening, including the time between when one of the power stations was destroyed, but before the second one was destroyed. And scientists were analyzing these images within hours because basically, as soon as we get them on the ground and we've processed them, they go out in our different platforms like Planet Explorer and the APIs. And so we had teams of scientists that were sending screenshots from Planet Explorer back and forth on Twitter, trying to do essentially forensic investigation and figure out, okay, this doesn't actually look like there's any evidence here for a glacial lake outburst flood. So what was it? And then they ended up paying us at Planet to say, hey, we think we see where the source region for this is. Can you task some SkySat to get a higher resolution look so we can investigate more? And this is what those 2 images look like. So this is the before. The first power station is around here. The second one is over here. Hopefully my mouse is visible. The flood started at about 4:55 UTC, I believe it was. So we have the before and after here. And this is the dust cloud getting kicked up by the flood as it was moving down this valley. And this is the SkySat image that we got after the scientists pinged us and gave us the coordinates that they wanted us to take a closer look at. And we could very clearly see where the rockfall site was. So the hypothesis after they got this imagery was that this was actually a glacier that detached from the slope here, fell almost 2 kilometers, essentially straight down into the valley floor, melted from the heat of friction upon impact, and then caused this really destructive flood that moved downslope. And then they were able to track things like this is the dust that was deposited on top of the snow and ice through the valley as the flood was moving downhill. Another big example that we saw in a natural disaster application is from the Sulawesi earthquake in 2018. And this is a case where there was a magnitude 7.5 earthquake that struck near a provincial capital city called Palu in Indonesia. And this ended up triggering a tsunami and some of the largest soil liquefaction mud flows that have ever been observed. It killed about 5,000 people and it destroyed a ton of infrastructure in the region. And this is an area that is prone to large earthquakes quite frequently. So it was kind of confusing about why it suddenly triggered all these mud flows that hadn't been a problem before with large earthquakes. And so Kyle Bradley and his team out of the Earth Observatory of Singapore used PlanetScope images taken directly before and after the earthquake so they could try to figure out exactly what was triggered by the earthquake and figure out what was causing the landsliding and if there was anything associated with those specific areas. And they were able to correlate the locations of the mud flows with specific types of rice farming practices that had actually caused the water table to rise to such a shallow level that the shaking of the ground just led to this soil liquefaction all over the entire island. This is a wide angle before and after view. I don't know why it stopped playing. There we go. So this is all the sediment that was deposited into this river and then flowed out into the bay here. You can see some large scale destruction along the coastline here, like this dock disappearing. If we zoom in to take a closer look, the ground here actually moved about 10 meters in the span of a couple of minutes, which anybody that studies earthquakes knows that's a pretty amazing amount of movement in such a short period of time. So you can see here some of the flooding damage near the coast. You can see some of the destruction to buildings here. And then again, this is that dock that we could see in the wide angle view. Huge changes in this area in particular and kind of inland over here. So Valsatina at the University of Oslo was able to use this data within hours to create a displacement map with just after the earthquake, so they could actually see how much the ground had moved on either side of this fault line. And again, this is the kind of thing that would not normally have been possible within just a matter of hours of an earthquake like this. We're also seeing a lot of applications in hydrosphere, looking at things like tracking blocks of ice in Arctic rivers and then calculating the velocity of them from how much the ice has moved between two frames of overlapping satellites. You can also do things like NDWI, Normalized Difference Water Index, to do flood mapping. We're seeing folks combine our data with things like SAR and LIDAR to get more topographic information when it comes to flooding. And I'm seeing a really big uptake in publications that are looking at things like tracking marine plastic debris, kelp, sargassum, things like that. We also saw some water quality studies come out looking at the changes in total suspended sediments from COVID lockdowns. And this is a paper that came out pretty quickly in 2020, looking at the sediment in the canals around Venice. So there were lots of reports on the news about the waters of Venice clearing up, and it was actually quite visible in the planoscope imagery. And so the column on the left here is the total suspended sediment concentrations before the lockdowns versus during the lockdowns. And if you actually just look at the imagery itself, you can actually start to see some of the structure of the terrain beneath the water as the density of the boat traffic, and then hence the amount of sediment that's being kicked up by the boats, but also just the turbidity of the water from not having the boats drive through it. It's quite striking before and during the lockdowns. We're also seeing folks look at methane emissions in places like the Arctic, and in this case, in the continental United States, seeing how the size of lakes changing over time can be related to methane emissions by combining the satellite images with measurements on the ground. And so Kelly Honjula used 421 planoscope images over more than 5,000 separate forested wetland areas over the course of a year, combined with ground measurements that she was taking at some of these locations to try to see how much did the lakes change in size and what did that correlate with in terms of the methane emissions that they were measuring on the ground. And they found that these very small wetland areas are responsible for the majority of methane emissions in the areas that they were looking at, and they weren't resolvable at some of the lower resolutions like Sentinel-2, for example. And so any estimates that are being made on those lower resolution data sets might be severely underestimating the amount of methane emissions that are coming from these smaller wetland areas. This is another example from some folks at Scripps that were using our data to look at the changes in shorelines from Cyclone Oma, which struck the eastern coast of Australia in February of 2019. Obviously, in a situation like this, it's really difficult to capture imagery because there are clouds in the way from something like the cyclone, but they were able to capture images with enough holes through the clouds where they could see the changes to the shoreline immediately before and after the cyclone hit. And so here are the examples where they were outlining the pre and post OMA shoreline based on looking at the high tide line, so the wet versus the dry sand. And this was not something that was resolvable at either Landsat or Sentinel resolution. And they were able to take this and do it on a couple 100 kilometers worth of coastline to then create a map of net deposition versus net erosion along the shorelines of this entire area of Australia. We're also seeing an uptake in folks using our data for atmospheric studies, which has been really interesting to see because we don't have any bands that are really specifically geared toward doing atmospheric science. But thanks to things like machine learning, we're seeing an uptake in things like using machine learning to combine planoscope imagery with air quality monitoring stations on the ground to get an idea of essentially if something looks this hazy from orbit, what is the correlating the corresponding PM 2.5 level. And there's a group out of Duke University led by Mike Bergen and his students and postdocs, where they've been doing some really amazing work on this front using random forest regressors to train models over certain areas. In the case here, they trained a model over Beijing using the air quality monitoring station data on the ground combined with our imagery over the course of multiple years, and then ran that same model over Shanghai and got really good results without having to incorporate the air quality monitoring station data on the ground. And so from this, you can actually start to take these models and apply them to places where you don't have a lot of ground-based data because it is quite expensive to build and maintain these air quality monitoring stations. And then from this, they were able to create near daily maps of air quality. They did them at 200-meter resolution. You could do them at higher resolution if you want to, since the data is much higher than that. But since they were looking at sort of broader scale studies, they made them at 200 meters. We also see a lot of studies in the cryosphere. This is one of the largest areas of research where our data is being utilized to look at things like permafrost slumps, glacial surges, just tracking the flow of glaciers and glacial calving over time, things like that. In July of 2020, the last intact Arctic ice sheet in Canada collapsed due to a combination of warmer air temperatures and offshore winds. And this was a case where we actually had some folks on the Landsat science team reach out to us and ask if we managed to capture imagery of this because the Landsat flyovers the day of the collapse were cloudy. In the Arctic, the satellites actually get really crowded in their orbits because we have so many of them. So you'll end up with multiple passes per day, and sometimes even multiple passes per hour. And so on the day of the collapse, we had at least 4 separate satellites that collected images. 3 of the collections were cloudy, but one of them was clear enough to get this after view here. So you can see there's a few clouds, but all the images taken after this that day were completely clouded over. You couldn't see anything. And if we look at the images from the day before, we also had 4 or 5 separate passes of the doves that day. So we were able to constrain the time of the collapse to a 10-hour time period. This is an example from Sarah Cooley, who was at Brown University. She's now at the University of Oregon. And she actually did these really broad scale studies of lake dynamism to track essentially how did the size and extent of these lakes change over time across broad swaths of Alaska and northern Canada. And she found that in some places, the lake shorelines fluctuated much more than previously known. And so very similar to the case that Kelly Honjulu was doing in wetlands in the continental United States, this is a place where there might also be more greenhouse gas emissions than previously thought because we weren't able to capture the full range of lake dynamism at this resolution. And so she was able to create these maps of seasonal dynamism over time for these 4 different areas across Alaska and northern Canada. So if you aren't already accessing data through the CSDA program, let's talk a little bit about how you can do that. So through CSDA, data is available to any researchers that are funded by NASA, the National Science Foundation, or any US federal civilian agency. So it's a really broad swath of researchers, which is really fantastic for the research community. So thank you, NASA, for doing that for scientists everywhere. And the data is available for scientific, non-operational research purposes. And the agreement includes access to our Planoscope daily data with a 30-day latency. So data acquired 30 days or more ago is what you'll be able to see in our catalog. Also, the entire Rapid Eye archive, and this comes with an initial quota of 5 million square kilometers per user. If you need increases to that, or you're working on something where latency is an issue, there can be exceptions to those made on a case-by-case basis. Right now, the agreement does not include any SkySat tasking or archive access, and it doesn't include access to our base maps, which are our cloud-free mosaics of the best quality images over a specified time period. If you have any questions about the program or getting set up, or if you have an account, you have questions, our email where you can reach myself and JJ, who is on the line here as well, is nasa_cs@federal.planet.com. Since we get a lot of questions about the imagery usage terms through this, I wanted to include this slide, which again, you'll be able to reference later. And this information is also available on the CSDA website. So the imagery can be used under what we call a scientific use license, and this is meant to be very intentionally broad. It's meant for non-commercial research purposes and non-operational work. And any derivative products that you create, like maps or figures, can be used in things like conference presentations, journal publications, media releases about your outreach, about your research. Basically, anything where you would need to publish some annotated version of the data in the normal course of your work, you can do that. You don't need to get extra permission from us to do that. We want you to be able to share those products that you've made. The only thing that you can't share is the original imagery, the GeoTIFF files that you download from us, with anybody that is not registered through CSDA. So if you're working with your collaborators at NASA or another government agency or a university that's funded under your same research grant, as long as they've signed up for the program, you can share the imagery among those groups, but they need to be a registered Planet user to be able to do that. If you create something like a map or a figure, it would be great to note that the imagery is from Planet in the figure caption. And then we have a publication that we ask people to use as a citation if you do use Planet data in your work, which is referenced at the bottom here. If you want more information, we've got a website that's just go.planet.com/NASA. The Apply Now button links you to the actual NASA CSDA website, so you can fill out the form. You just put in your information. Usually takes maybe 2 or 3 weeks for the applications to be processed. And once you've been approved on the NASA side, you'll get an email from us at Planet that sends you all of your login information and some onboarding documentation to get started. And if you are using the data now or you're going to use it in the future and you're going to publish something or present at a conference, definitely let us know, because we like to see the kind of stuff that people are doing with the data, like the examples we've presented here. And if you're doing something really cool, we'd love to promote you on the Planet blog or social media, or if we're going to be at a conference, promote to other people that are going to be there that you're giving a talk or a poster, stuff like that. So to get into some of the nitty-gritty of like how Planet defines the imagery that we collect, because it's not exactly the same in some cases as what you might be used to working with something like Landsat or Sentinel. Basically, as the doves are flying along in their orbit track, they take a bunch of tiny overlapping images that we call scenes. And so you'll see the overlap in the hopes of creating, gap-free coverage from a day-to-day basis. Since the doves don't have any propulsion on board, there is a little bit of drift. So sometimes you might see like gaps here and there if the orbit tracks don't line up exactly. And there's a few different data products that we have when you log in and do some searching for the data, which we'll see an example of in a bit. We basically have basic scenes, which is a scaled top of atmosphere radiance product that hasn't had any corrections applied to it. So if you want to process basically the rawest form of the data, you can start there. But then we also have ortho scenes and ortho tiles, which have had different levels of corrections applied to them based on what you might want to do. So we have a visual product, which is the top of atmosphere radiance, which is an 8-bit product. And then we have surface reflectance products, which are analytic 16-bit products. And then these, for both the ortho scenes and the ortho tiles, have been atmospherically corrected if you have the surface reflectance product. And for any of the products, they've been ortho rectified and terrain corrected. For the ortho tiles, these have actually been stitched together, the individual scenes, to create these 25 by 25 kilometer tiles if you need just like a straight out of the box image that's the same size. This is really convenient if you need something like that, because the footprint size of the doves has actually changed over time as we increase the size of the sensor. So the ortho tile gives you a way around that. And if it's hard to visualize what that means, this is what it looks like. So we have the stripe of individual scenes, and then we overlay that on a UTM grid and then chop out the 25 by 25 kilometer boxes. And then that's what you get for your Planescope ortho tiles. But if you just want the individual scene and you don't care about the footprint size, you can download the ortho scene product instead. So there are 5 different ways you can interact with the data depending on how much data you need to download and how command line savvy you are or what type of software you like to use. The easiest one for folks to get started is Planet Explorer, which is our graphical user interface that we'll take a look at in a minute. And this is great for browsing around, clicking on the map, and downloading small amounts of data, so less than 100 images at a time. If you're working in something like QGIS or ArcGIS, we also have integrations that are built directly into both of those software packages, which is basically like running Planet Explorer natively in QGIS or ArcGIS. And so you can use that to download the data directly into your projects. And this can be really handy if you're working on, say, you want to use like your own custom map for looking at the imagery or browsing where the footprints cover, since we don't have an option to upload raster data into Planet Explorer. And then we have some command line interface and API options. And this is if you're like really savvy with Python, or you've got maybe some developer experience, you're not afraid of working at a command line. And this is really good if you want really fine-tuned controls over the different filters, or you need to download massive amounts of data. Like if you want to download, you know, all of the state of Alaska every day or something like that. We have people that are doing, studies at that scale. So you can actually set up something through our API. We have a subscriptions API where you can do things like that to just pull down data that meets certain requirements on a recurring basis. And you can put that, say, in your cloud bucket, or you can put it on your local machine, wherever you need that to go. So for Planet Explorer, you just go to planet.com/explorer. Once you've gotten your account approval from NASA and you get your login information from us, you can go and log into Planet Explorer and start browsing through the data. Some people get confused and they go to Planet Explorer and create a trial account thinking that that gets them signed up for NASA. That won't work. You actually do need to fill out the application form on the CSDA website and have us set up your account first. Otherwise, you'll just have a trial account and it won't let you actually download anything. So if you've done that and got confused, definitely ping us and we can try to get your account moved over to the right place. So Planet Explorer is pretty user-friendly, especially if you're used to using things like ArcGIS. There's a search option. There's a place where you can manage the orders that you've already placed, and you can download the images that you've placed in previous orders or check the status of orders that are pending right now. So you'll see some changes to the filters if you've been using Planet Explorer before to seeing some of the different options that we have now with the SuperDove satellites. One of the big changes that you're going to see that we'll talk about in a few slides is that we've moved away from having separate 3-band and 4-band asset types, and everything is now under a single package called a PS scene. So you'll see that here, PlanScope scenes, and then we have those ortho tiles that we were just talking about. This is to make it way less confusing when you're doing searches, because before, especially if you were looking, say, in a coastal area or the cryosphere, you might get different numbers of search results if you look at 4-band data versus 3-band data, just based on, say, if your near infrared band couldn't be aligned properly with the RGB bands over something like ice. And so you would actually often have more 3-band search results than 4-band in some of those areas. Now you don't have to get confused with any of that. You can just search all at once, but you can turn on different filters. So by default, the 4-band data will show up, which is the RGB and near infrared with this checkbox here. If you want the 8-band data, you can also click the checkbox for coastal blue, green, yellow, and red edge, or you can filter by specific instrument type. So Dove Classic, Dove R, or SuperDove, if for some reason you only want imagery from one particular type of satellite. You'll also see the options if you're downloading surface reflectance data. This will give you that harmonize option for the Sentinel-2 data sets. That option will not show up if you download just the visual data. It will only show up in Explorer for the surface reflectance. You can also decide if you want to clip your imagery to your area of interest, or if you want to download the whole scene through this clip items to AOI button. We've also added some features to Explorer where you can do some on-the-fly visualizations if you just want to see sort of the quality of the data before you actually place an order to download it somewhere. And this is under a tab over on this side of the screen, which we have called spectral indices or enhanced imagery. And we've got some of the standard indices in here, like color infrared, and then NDVI, NDWI, and a few other ones. If there are any indices that you would like to see in Planet Explorer that we don't have in this list, definitely let us know. We're always happy to add functionality based on what folks want to see. But this is not really meant to be for rigorous scientific analysis. This is more just like a quick visual. Can I see what I'm hoping to see in this image, or do I need to download a different one or a different day? But it gives you a quick idea. The enhanced imagery options, which would show up here if this was actually in Explorer. sorry, the WebEx interface is covering what I'm trying to show. You can actually also do changes to things like the brightness and the contrast, which again can come in handy in places like the Cryosphere, where the thumbnail of the image in Explorer might look really blown out just because of the default stretch that's applied planet-wide. But a lot of those images actually do contain a lot of detail. It's just the thumbnail is a little bit deceptive. So if you're seeing data that looks like that, you can bring it into this hosted data option, play around with the stretch and see, okay, can I see the things that I want to see in this data or not? If I can download it. If I can't, move on and look for imagery from another day. So I mentioned before, we're putting everything under this PS scene asset type. This gives you access to the 3-band, 4-band, and the 8-band data. If you were working with any of the 5-band data that we had before, this was the SuperDove data before we released the rest of the bands. So that data is still here, but it's encapsulated now under that 8-band product. This data is the stuff that's been calibrated to Sentinel-2, and you could access it through Planet Explorer plus all of our different APIs. If you have a script that's set up right now that's pulling specifically like, PS 3-band or PS4 band, and you need help altering it to call the PS scene assets instead, definitely ping us and we can help you adjust those scripts if you need to. The 3-band and 4-band asset types that we had before will still be available via the APIs through the end of this year. But after that, they will be deprecated, and everything that you will have access to through the APIs and Planet Explorer will be these PSC and asset types. So you have some time to migrate your scripts over if you're using those right now. These new asset types are also available through our integrations, so QGIS, as well as Google Earth Engine. I didn't have that in the list of access options, but it is another option where we have an integration. The data is not natively hosted in Earth Engine unless you're using base maps through our NICFI program. You do have to download the imagery to wherever your bucket is and then upload it into GE for the time being, at least. And like I said, the integrations are basically like running Planet Explorer inside of one of these packages. So you can apply the same search filters. You can preview the tiles in your map interface that you're using. You can still filter for specific sensors like SuperDove versus Dove Classic if you need to. And we also have an option now where if you're specifically looking for only surface reflectance assets, you can filter for that as well, because every once in a while you might have say a 3-band product where we didn't have the ability to generate surface reflectance, or something went wonky in the processing and there's a visual option but not a surface reflectance option. Now you can filter it so that you don't end up downloading any data where there is no SR asset if you specifically need that. You can still access and order your legacy image types through any of the save searches that you have, but since those are going to be set with your 3-band or 4-band options, you'll be prompted to update those to the new PS scene asset type when you try to go and run these if you're using these through the integrations. And again, this looks very similar to the interface in Planet Explorer. You can see the different things that you want to set for your order, like do you want the top of atmosphere radiance? Do you want surface reflectance? Do you want the 4-band or 8-band assets? Do you want to harmonize, or do you want to clip the data? So you should be able to migrate between the integrations of Planet Explorer pretty freely. And this is kind of what we already went over. So I mentioned before, we have 3 different APIs that you can use to interact with the data. There's a data API, which helps you discover what planet data is available over your area of interest. And then we have an orders API that you can use to place single orders, or there's a subscription API where you can do ongoing orders. So that's the example I gave before of if you have a huge AOI, or even just a small AOI, it doesn't really matter what size it is. If you have an area where you want data to be pulled on a recurring basis, you can set it up through the subscriptions API. These can be kind of tricky for folks to use if you're not a developer-minded person. So this is another thing where if you want to play around with these, if you need a subscription order set up, or you need to place like some huge bulk download order and you're not really sure how to get started, reach out to us and we can help you write custom code to do that, because we know that it's not always the most intuitive thing to do if you're not used to interacting with APIs like this. So for the subscriptions API, you can have images delivered to a bunch of different cloud buckets. So if you're using Amazon, Google, Microsoft, Oracle, we can do cloud delivery to any of those. We can also do it to on-prem sites as well if you're working with a local server. But if you're doing huge downloads, it's a lot easier to do it through the cloud because you're probably having massive data volumes. Another thing that you can do through the APIs is you can do band math on the fly, which is not something that is available through things like Planet Explorer. Now you can download options for chlorophyll index, NDRE, and NDVI, and you can do up to 15 different calculations per order. So you could say, okay, I want NDVI products of this AOI and set all of your filters there, and it will give you the calculated indices in the products that get delivered to you. You can also set the harmonization options through the APIs. So the default now, like I said before, is Sentinel-2. If you, for some reason, want the data still harmonized to RapidEye for the older data sets, that's also an option through the APIs. I believe that option will still be available even after we deprecate it from the graphical user interfaces. JJ, if I'm wrong, you can say that in the chat, but I'm pretty sure that option will still be there so that you can make sure that the data that you're working with, if you've been dealing with the RapidEye calibrated data for multiple years on research, you can still have consistency across the data sets. We have a ton of resources online to help folks get started, including a detailed product specs guide that goes into the details of the satellites, all the different image products, the metadata, anything you might want to know is in that document. We also have a technical support center, a developer resource center, which has a lot of API information, some technical white papers on things like the harmonization process and the radiometric calibration. We also have a Planet Science update, which is a newsletter that comes out once a month that features links to our upcoming training sessions. We feature publications coming out of things like the NASA program and some of our other science programs. We list funding opportunities in there and any other big product announcements like this. It's a really great resource for the community, so I highly suggest registering for it if you don't already get it. If you sign up for a NASA account, you will automatically start receiving them so that you're in the loop on all the trainings. And again, these links will come out so you can click on these when you get the slides later. And speaking of trainings, we run technical trainings for the research community 1 to 2 times a month, depending on timing. The next one is April 28th at 9 a.m. Pacific, noon Eastern, which is going to be focused on radiometric calibration of PlanetScope and SkySat data, hosted by Dr. Hannah Bourne, who is one of our scientific geospatial software engineers. So she's going to be talking really nitty-gritty details about how we actually do the calibration. And I know that's something this community often has a lot of questions about. So definitely tune in for that. If you can't make it live, these are recorded and then we put them on YouTube afterwards as well. So if you register, even if you don't plan on attending live, you'll get an email link to watch the recording later. And I love to finish these for anybody that hasn't been using Planet data to think about what would you do if you could see daily change of anything anywhere in the world. And with that, does anybody have any questions?
Hi, Tanya. Yes, we do have questions in the chat, and some of them have been answered, but we want to thank you for this outstanding presentation. A lot of great information, and we want to let everyone know that this data is available to you. So, Tanya, we'll go to the chat for I know some specific planet questions, and I know Kevin and Manil answered some of the CSDA type questions. So we will go to there. The first one was from Emil. It basically says that thus far the monthly plus other mosaics have all been VNR or full band. Are there plans to generate 8-band monthly, weekly, quarterly mosaics? And would there be a way to access those through the CSDA program?
So right now, the base maps, which is our name for the product that you're referring to, the mosaics, they aren't available through the CSDA program. Definitely let Alfreda, Manil, and Kevin know if you would like that. We
Okay.
can create 8 band, but they're considered custom at this point. So the standard base maps that we generate all the time are the weekly, biweekly, monthly, and quarterly 4 band mosaics in both visual and surface reflectance. We can do them on custom timescales if people need that, and we can do them 8 band if you need that. Those are ones that are generated like on the fly as people request them.
Okay. Thank you. Yeah. Currently, base maps are not included in the program. Let's see the next one. It's from Mark, I believe. Are there plans to do complete reprocessing of Planet SuperDove record with the new calibrations and corrections? Great question.
Yes. So the all of the corrections that we talked about today, they will be applied to all of the historical SuperDove data. Right now, they're going on the fly from March 1st moving forward, and it should probably be a couple of months. We don't have an exact date yet, but sometime in the next couple of months, the rest of the archive should be reprocessed as well. I don't think, in terms of the hot pixel corrections that we talked about that go back to August of 2021, for the non-SuperDove data sets, I don't think they're going to reprocess the rest of the archive, but I could be wrong there. They didn't mention anything about reprocessing them yet.
Okay, Mark, did that answer your question? Let's see. The other one is also you noted band-to-band registration is down. Um, it's down to 1.5 meters. Have you characterized the registration between the different satellites in the SuperDove constellation? This is also from Mark.
I'm not sure if we've characterized it at the individual satellite level. I could check and get back to you, but I don't know for sure.
Okay, I guess you could, if you could take a note to check on that,
Mhm.
appreciate that. Okay, let's see. There's a question about access of the archive SkySat data through the program, and Manil did answer that what we have from the pilot, as well as some limited amount of SkySat is available. The SkySat data is available to the users, and Manil answered that question. There's a question regarding um, will there be future opportunities for algorithm development and or data processing approaches for planet data? That was directed to Kevin, and Kevin answered it that there will be future ROSES elements that support research and application with sister data. So ROSES element 2022 have a future element there. Okay, this is from Taylor. Thanks, Tanya. Is there a process for the community to provide input on band configurations for future generations of doves?
Absolutely. Any ideas that you have or suggestions that you have that would be useful to your specific research area, we're totally open to hearing that because we want to make sure that we're building satellites that are useful for the community. Um, so there's not really a formal process. It's mostly just, hey, send us an email and let us know what you think would be cool. And there's always opportunities where, if it's something that we think is particularly interesting, sometimes we can fly tech demos or we'll do collaborations with universities to do just like, hey, let's change one thing in one of the doves in our next launch of 50 doves and like test this out on the satellite, for example. So yeah, we're always open to getting feedback from the community.
Okay. Um, Here's one from Call. I believe, could a user input a specific algebraic operation to have the math band applied to images within a prescription order, a subscription order?
That's a good question. JJ, do you happen to know the answer to that? I think you can, but I've never tried before.
Yes, we can provide different band math. applications or algorithms, and then yes, I believe you can essentially have it created so that upon delivery, it's in NDVI or whatever spectral indice you wish.
I guess if you wanted to put in a custom one that's not the standard
Oh,
ones we have built in, can you do custom band math through the API?
Yeah, this is Carl. I'm the one that asked the question. What I had in mind was if we develop a calibrated relationship between some water quality parameter and various bands from the planet scope constellation, could we put that in so that as we're ingesting images, that calculation is automatically applied to produce a map of turbidity, for example?
I'm not sure. I would have to double check. I think you
Yeah.
can, but I've
I mean,
never
it's something we
tried.
could do easily after we download it, but it'd be really slick if we could just pull that as essentially an end product directly from the Planet platform.
Yeah, absolutely. I mean, if you don't need the component images, why have them sitting on your hard drive taking up space?
Yeah, yeah. So, okay,
Okay.
well, put that on the feature request list, I guess.
Okay. Yeah, I'll look into that and get back to you. I know we did add the option to be able to download specific bands rather than having to download everything. And I think
Uh-huh.
with that addition, there's now the option for custom band math, but I will double check to make sure.
Okay, great. Thank you very much.
Okay, and our last question came from Fritz. Can you comment on Planet findings on absolute geospatial accuracy and any continuing work on this?
So as far as I know, we haven't been doing any work on improving geospatial accuracy. We've been really focused on things like the band registration because that was such a big hurdle to overcome with the SuperDove data and the image sharpness improvements. Um, it's certainly something where this has come up from the community before, and so I can take this back and say, hey, now that we've tackled the big things, this is the next thing on the list coming from the community. They would really like to see better geospatial accuracy. Part of it is just a side effect of the fact that the satellites don't have any propulsion on board, and so there's not absolute pointing compared to something like a Landsat or a Sentinel, and so it's not the geolocation is never going to be as exact, but certainly we can try to work on algorithmic improvements so that we can look at can we use adjacent scenes to better figure out where this goes, because usually the process is based on looking at feature matching from previous images that have been taken in an area, which can lead to some geolocation accuracy issues if you're looking at an area that's changing a lot, like coastal regions or glaciers. So you'll see differences in geolocation accuracy based on the type of features that you're looking at on the surface. They're generally not huge, but they will vary over different places on the planet. And so it's something that we know is an issue, but it has been a lower priority to focus on compared to the changes that we're announcing in this webinar today.
Thank you.
All right. Well, thank you. Thanks everyone for attending. We're at 1:59 is what I had. So we did a great job in managing our time. Thanks again, Tanya, for doing this outstanding presentation for us. We will provide this after the lunch and learn out to everyone so that you can have it. And feel free to send any additional questions to us. It's for CSDA, and we will do our best to answer them. And if Tanya could take those few actions that we have and provide feedback back to us, that we would certainly get that out. Again, thanks a lot, everyone, and have a great day.
Yeah, thank you very much. Have a
Great.
good afternoon.
Thanks so much, everyone.
Bye-bye.
Thank you. Thank you. Thanks, Kevin.